Hi students, welcome back to ChemOrgChem. So in this JEE Chemistry Insight series, we have been exploring the solution for previous year JEE Chemistry exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So here is the question. So this is the question from JEE Main 2025. As per this question, which one of the carbocations from the following is most stable? And we are given four different carbocation structures. So let's take a good look at each one. So let's see our first structure. We have a carbocation and that carbon is allylic carbon, meaning it's right next to double bond. And further down the chain, so here you can see that CH2 O CH3 group. And next moving on our structure 2. So here you can see that this carbocation also allylic carbocation. So here it contains one methoxy substituent. And moving on our third structure, again this one also allylic carbocation that contains ester functional group. And fourth structure, so this is our final option. So we have on allylic carbocation next to fluorine atom. So here definitely there will be $1 million question. Which of these carbocation is most stable? To answer this, we need to think about what are the factors that important to stabilize a carbocation. Let's briefly see about what are the important factors that affects the carbocation stability. So the first one is resonance. So delocalization of the positive charge through pi bonds that enhance the stability of carbocation. So the next one is hyperconjugation, the interaction of sigma bonds, usually CH bonds, on adjacent carbon with the empty p orbital of the carbocations. So we know that carbocation contains empty p orbital. So therefore, near CH bond that can effectively stabilize the carbocations. So the final one is inductive effect, more perfectly plus I effect. The electron donating groups, for example, alkyl groups attached to the carbocation that can increase the stability of carbocations. Conversely, so if electron withdrawing group directly attached to the carbocation that can potentially destabilize the carbocations. So now we are clear these three important factors that affects the carbocation stability. Based on these three important factors, we are going to solve our question. So let's moving to our question. Looking at all the four structure, the first thing we noticed is that in each case, the carbocation is allylic. This is a huge stabilizing factor because the positive charge can be delocalized through resonance with these pi electrons of the double bond. So therefore, here we should need to think about, apart from this double bond, what other substituent present in this double bond. So based on that, that affect the carbocation stability. The first one is here you can see that. So here this carbon attached with CH2O CH3 groups. So we know that CH2 group that can donate the electron by plus I effect, since alkyl group is electron donating group. At the same time, this CH2 group can stabilize this carbocation by hyperconjugation. So this based on two effect that can stabilize this carbocation. So now moving on our second option. So here you can see that now this double bond attached with methoxy group. So here particularly you should look the oxygen atom. We know that oxygen has one of the more electronegative element that can pull the electron from this carbon by inductively. So therefore, minus I effect potentially destabilize this carbocation. So apart from that, oxygen has two lone pair of electron. So that lone pair of electron that can contribute this carbocation stability by resonance. So therefore, this oxygen can donate the electron by plus M effect that could stabilize this carbocation. So let's moving to our third option. So now you closely compare our second option and third option. In second option we have methoxy group. However, in third option we have ester group. So ester group potentially withdraw the electron from this center by minus some effect. Why like this? So here you should look that. So this oxygen atom, just like this oxygen atom, which has more electronegative power, that pulls the pi bonded electron towards this oxygen atom, which makes that this carbon is electron deficient. So therefore, this oxygen can readily donate the electron towards this carbon atom rather than this carbon atom. So therefore, the donation is less effective towards this carbon atom compared to this carbon atom. So therefore, this ester group potentially withdraw the electron from this carbon by minus M effect, which destabilizes this carbocation. So let's moving on our fourth option. So here you see fluorine atom directly attached to this double bond. So we know that fluorine is one of the most electronegative element that can pull the electron from this carbon by minus I effect. While fluorine does have lone pairs that can participate in resonance, for example plus M effect, its strong electronegativity makes this donation is less effective compared to oxygen in methoxy group. The strong pull of electron density away from this positive charge makes this carbocation is significantly less stable. So now you see, so in option 3 as well as option 4, there is a T stabilizing factors. Because of destabilizing factor, these two carbocations may not be a most stable carbocation. So now let's think about option 1 and option 2. So option 1, this carbocation can stabilize by plus I effect and hyperconjugation. In case of option 2, this carbocation could stabilize by plus M effect of this methoxy group. At the same time, minus I effect that can potentially destabilize this carbocation. So when you get this type of situation, you always remember this rule. So according to this rule, mesomeric effect always get more preference when compared to hyperconjugation and inductive effect. So inductive effect one of the least preference one. So therefore we can forget about the inductive effect. So now you compare the hyperconjugation and plus M effect. So according to this rule, mesomeric effect we should give more preference. So therefore, the most stable carbocation would be option 2. So let's moving to the our question. As per our discussion, among the four carbocations, the most stable carbocation is option 2. That's it for today's problem. I hope these carbocation related problems has helped you to understand this concept as well as this question. If you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.